First question is one where you really do kind of have to do this by hand. It's asking you, in this case, to put it into general form, which means expand it out. And so what you're really being tested on is you keep the number out front. The leading coefficient stays the same for all forms. So we know it's going to start with 6. We expand this binomial square. And the binomial square rules is we square the first term, x squared. We take the product of the two terms and double it. X times a positive 4 is 4x. Doubled is 8x. And then the last term we square. Positive 4 squared is 16. And then you have your minus 6 outside. We then distribute our 6. That gives us 6x squared. 6 times 8 is 48x. 6 times 16, if you think of the different parts of that, 6 times 10 is 60. 6 times 6 is 36. 60 plus 36 is 96. And then the minus 6 carries along. And we only have two like terms to combine, so we get our answer, 6x squared plus 48x plus 90. So that would be our answer for that. Right, there's really, Desmos doesn't really do much for that. Now the next one, though, is one that if you're doing it by hand, you would do completing the square, which can be a more complicated type of problem. But because we know that vertex form is y equals a times x minus h squared plus k, we know our a value is the same for every form. Our a value is -2. So already we can write this part of our answer, and we just know we need to fill in what goes inside the h and what goes for the k. Well, the nice thing is Desmos can give you that just by looking at the graph. So if we type our function here, and I do tend to use function notation. You don't even really need to put the y equals or anything here, but I'm going to. Negative 2x squared plus 20x minus 53. And when you see that, all we need to know is what the vertex is. The vertex is 5. Oops. And the k value we see is -3. And so if we plug in a 5 and a -3, we have our answer. Notice the next question, it's asking the same thing, basically, right? What's the vertex? We just need to know the hk value. And so once again, if we type that into our problem, we get 9x squared minus 3x minus 1. Hey, the one thing to make sure you keep in mind, when you select a graph, so you can select a graph by either clicking the equation itself. Notice when I click this equation and highlight that, the graph gets highlighted. And anytime you see the points on a graph that you see are these critical points, you see the x-intercepts, you see the y-intercept, and you see the vertex. So notice I had to scroll in a little bit more to see my vertex. And so I get my vertex to be 0.1667 and -1.25. And that would be my answer. Sounds like I should not have rounded those decimals. Is that correct? Okay. Yeah. All right. So finding that, you can enter your answer as a rational form, the decimal form like this. Okay. So if you are going to do that, give yourself enough decimals that it might meet whatever tolerance level it has. If you put 0.17, and then it might mark it wrong. That might not be a big enough tolerance or a small enough tolerance difference. So make sure you give yourself 4 or 5 or more decimal places when you're writing that. All right, so this is the question here, again, that when we did the assignment, that wound up, it just seems like it's a lot of parts to it. But really, it's all done by just doing one thing, and that is typing this equation into Desmos. Okay, so if we type in negative 1x squared minus 2x. Okay, so first of all, it's asking us to do the following. Sketching the graph. So there'll be a little graph button that you click here. Remember, a graph for a parabola is designated by 2 points. The first point has to be the vertex. So if we find the vertex here and just click, -1, 1. So if we plot that point, negative 1, 1, that's our first piece of information. And then the second piece is any other second point. The second point can be anywhere. Now, since we're asking for y-intercepts, we might as well use our second point as the y-intercept, 0, 0. So if I click my second point right here, after 2 points, the graph is going to automatically fill in for you. Okay? Once you see that, again, you'll be able to answer all the questions just like what you see on Desmos here. The x-intercepts, here's our other x-intercept, negative 2, 0, and 0, 0 is still an x-intercept. The domain for parabolas is always all real numbers. There is no limitation on the x's. The lowest x is negative infinity, the highest x is positive infinity. With the range, though, there is going to be a limit. Okay? So always look, the domain and range always go just like a number line. To the left is the least, to the right is the greatest. So we want to find what is our lowest y value. Well, when we look here, it keeps going down. And so what's the lowest y value going to be? All the way to negative infinity, right? It's infinity in the negative direction. Okay, what's the highest value of this graph? It's 1. Again, we're looking at y values for the range. So the highest value is 1. Since 1 has a dot associated with it, it means it's included. Inclusion is a bracket in the interval notation. Infinities can never be included, so it's always a parentheses at a plus or a minus infinity. Okay, so that would be our range. And then finally, our axis of symmetry is always just a vertical line passing through the vertex. And so it's going to be the x-coordinate of your vertex. X is equal to negative 1 in this case. Okay, so that's how you would find all the different pieces for this question. Okay, and it's all done just by looking at that graph. Type the equation in, look at the graph.
By the domain, so if the graph was positive, like going the other way, would it be infinity then negative infinity?
No, it's always left to right. For x's left to right, for the y's, it's bottom to top,
So
lowest to highest.
So if it's just a vertical graph, then it's always going to be negative infinity first?
Yes. Negative will always be written up before anything else. Negative infinity is the furthest to the left you can possibly go.
But it depends on whether it opens up or down, right?
Nope, even if it, like, so if it opened up, the domain is still negative infinity to infinity. But the range now, like if this was the point, let's say 5, 3, where this is 3, now it would be 3 to infinity for the range. But the domain still is negative infinity to infinity. All right. So the next one, hey, we talked in our notes. If you look at your notes for this, what you're going to see is it is a relatively simple way to do this by hand. Okay? But we've already gone through that. You can do it that way, or you can do it the way I'm going to show you right here. Okay? And this is what I want to show you is how to use the regression equation functionality of Desmos to create an equation from just points. Okay? So if you're given this graph here and you want to find the equation that represents the graph, you always need one more point than the degree of your function. So a quadratic is a degree of 2, right? It's x squared. Okay, so we need 3 points. If we can find 3 points on this graph, we can use Desmos to find the equation of that. So here's one given point, negative 6, negative 5, right? That's what was given to us. If you just go straight across, the easiest second point to find, or one of the other third points that you need, is just look at the point that's level across the y's to this. Because the graph is symmetric, we know that that's a point. So negative 2, negative 5. And then use the vertex as the last point. The vertex we see is negative 4, 1. So once you get 3 points, and it can be any other points. I mean, you can find down here any other points that lie right on those grid markings. It doesn't look like any of the others are like perfectly aligned on the markings, so this is the ideal. Okay, but if you find these, what you can then do is go into Desmos and you can create a table. Okay? And this is also going to be on your SAT. You will have this ability to use this, again, on the SAT. If you build a table, so plus table, add table, and then you plot these 3 points. So -4, 1 is one set of points, -6, -5 is a second set of points, and -2, -5 is your third set of points. Once you do that, you can use what's called regression equations to find the equation of that line. Okay? And so what happens here is when I click this button, this little icon again shows up. It'll show up on the SAT as well. When you click that, it will add the equation. You choose what form of equation. We're looking at quadratic. And once you do that, it gives you the equation right here. So your answer is 1.5, which is 3/2, x squared minus 12x minus 23. Okay, so that gives you your answer. Okay, now, oops, let me go back. It's a negative 1.5, right? So -3/2 x squared minus 12x minus 23. Okay, now, here's the thing. If they specifically ask you to write this in vertex form, you can still use the form that they gave you in your regression equation. Because if they ask for vertex form, our a values never change, right? So even in vertex form, we're looking at -3/2 x minus h squared plus k. Well, we know our h value is -4, so minus a -4. Our k value is +1. And so we could have written our answer in this form too. So all we needed from the Desmos form is really just to find what this leading coefficient would be. All right, now I'm going to go off, and I'm going to go beyond just a little bit. Yep. Yeah, -1.5 is -3/2. All right, let me go off script here just a bit. This ability to click this icon up here and get the quadratic or get the regression equations was added within the last like 5 or 6 months. Before that, you had to know a specific code to write in. That code still works, and here's what's kind of like helpful in that is that code can still be entered, and it finds any form that you need. Okay, so if I want vertex form, if I want it to just show me what my answer is in vertex form, I can use the code, and the code is using y1, y sub 1, and using this button that's the similar to button. So if you don't have a keyboard when you're typing this in, you can pull up the Desmos keyboard and go into the alphabet keys, and it's right down here on the bottom line. So you can use that similar to button. And then if you just type in the general form that you want. So we listed this already, right? If you want vertex form, it's a times x, but again, instead of x's and y's, you're using x sub 1. So x1 minus h, quantity squared, plus k. Notice, now it gives me my a value, my h value, and my k value. My a value, my h value, and my k value. I have all of those there. Right, if I wanted this to give me my equation in intercept form, if you guys remember, intercept form is y1 is similar to a times x minus p times x minus q, right? So if you go x1 minus p and x1 minus q, you can look down, and it will give you your x-intercepts. Right? So again, let me double check on that one because that looks like numbers that are not the correct ones. But you can find your forms just by entering it in that scripted form, right? For the vertex form or the standard or general form. All right, moving to the next. All right, if you recall early on when we talked about some of the SAT review, anytime the SAT asks you to solve for something that's not just the variable, but it has the variable in it, so like 4t or 4x or 2x plus 1, if they ask you to solve for that, more than likely there's some direct way to create that in your solution. Okay, so doing this by hand and just isolating 4t on one side of the equation, that's probably going to be the easiest way to do it. I just want to show you, you can still do this with Desmos. On Desmos, if you write each side of an equation as a separate function, and then just look at where those two lines intersect, that gives you your solution point. So I can find what t is by typing 3 times, remember you have to change everything into x. Desmos doesn't understand any other variables but x and y. Okay, so if I took 3 times the quantity 2x minus 5 plus x as one line, and then on the right side of my equation I have 6 plus 3x as my other. If I find where they intersect, that is my solution. T is equal to 5.25. Therefore, my answer is 4 times 5.25. And if I do that here, my solution is 21. So that would be my answer for this. Okay, so you can still use Desmos to calculate these. And that's just if you have an equation that you're solving, just split it into each side of the equation into its own separate line and find where those two lines intersect. All right, the next one you just need to do by hand, and that is understanding how function notation works. F of minus 2 is asking us to find what is the output when the input is -2. Well, an input of -2 has an x coordinate of -2. We find where that is. It's the point -2 and -3. So the f of the y value for that is -3. So that one you just need to find. It doesn't require any calculating. It just requires an understanding. All right, keep on working. So factoring. When you factor, it generally is going to be easier to factor by hand. Right? You should be able to look at this and say, when I reverse FOIL this, what two factors of -10 have a sum of +9? Make sure you use the correct variables, but one is a 10 and the other is -1. There's your factors. Now, how would you be able to solve this on Desmos? Okay, so if you type this in as a function, or you don't even really need the y equals, but remember, turn everything into x's. So x squared plus 9x minus 10. The x-intercepts are your p and your q values, right? So I know from my graph that p is equal to -10, q is equal to +1. And so your factors are going to be x minus p, x minus q, and that's your answer. So you can still do that. If it's integer values like this, it winds up being really easy. Okay? If we try to do the same thing here for like the next problem, if I take this next question and I type in f of x is equal to 1 minus 25x squared. Again, it does still tell me, I could still see on my equation here, or on my graph, I see my two x-intercepts. But now notice their fractions, their decimals. Okay, so if I do that same thing for this, I know a couple things. My graph opens down, which means my leading coefficient has to be what? It's a negative, right? So I know I have to think about there needs to be a negative removed from this whole thing. So I do have a negative. And then I have x minus p and x minus q. So I have x minus p, x minus q. Well, let's look at our p value is -0.2, and our q value is +0.2. If I plug that in, so minus a 0.2 and minus a +0.2, it will mark that correct. If you type your x-intercepts p and q as decimal values, it should still accept it as being correct. Okay, now, the more ideal way to look at this would be if you can think of the fraction form of these. 0.2 is 2 over what number? 10, right? 2/10. So that means it's really 1 over 5 and -1 over 5. So if you reverse engineer your p and q values, if you remember when you have something like this, and I'm just going to write 10x plus 7. And if you want to find what 0 corresponds to this factor, my rule for you is take the opposite of the constant, divide by the leading coefficient. So when you are reverse engineering that, what you would do, you still need a negative in front, but you have x minus, you take the opposite of the constant over the leading coefficient. So you can rewrite it in this way. Take the negative, x minus the negative 1 over the positive 5. The denominator here is the leading coefficient. And so this would be sort of what the form is they're looking for, but the decimal should still work. Kara?
Could you just make the answer 1 minus 5x?
Yeah, I mean, that's the ideal way, by hand. So the faster way, for most of these, the faster way is just look at this. This is the base 1 squared, the base 5x squared. The difference of two squares factors into the sum and difference of those. 1 minus 5x, 1 plus 5x. Okay. Notice this and this with the negative out front are the same thing. Okay. Like I said, the by hand is the easier method for this, but if you do get stuck or lost, you can always put it into this form. The next example goes even further with that. Okay. Ideally, you solve this by hand. Okay. This is one where you either need to reverse FOIL and look at all the possibilities, and there's a lot of different possibilities. Okay. Or you can, because the middle is an odd number, to me, I'm just going to take my leading coefficient times my constant. Look to rewrite the middle term. What two factors of negative 60 give you a total sum of negative 7? Bless you. Bless you. So the fact that this outer and inner is an odd number means that one of these factors has to be odd. And so we know that we're dealing with an odd number here. So if we are testing these, we know that the negative has to be the larger of the number. So we can go plus 3 and minus 20. That's not it. Find the next odd number that's a multiple of this. Plus 5 and negative 12. Does that have the difference we're looking for? Yeah. So what I can do is I can rewrite my middle term as the sum of those, drop the first and last terms down, factor by grouping, take out a 5z, leaving 2z plus 1, take out a negative 6, leaving 2z plus 1. If I've done this correctly and it's factorable, I have my 2z plus 1, and then I have my 5z minus 6, and that would be my set of factors. Now, what if I wasn't sure and I wanted to test that? Remember, change everything into x's. So there are my two answers. Hey, the graph does open up, so I don't need to worry about putting a negative in front of it. Okay, and so I could have just identified my two factors are x minus my negative 0.5. That coincides with this factor, or z, sorry, z minus. And then z minus my 1.2. Once again, if you were trying to put these into fraction form, that would be 1 over 2. This is 12 over 10, or 6 over 5. And so you can see how you can recreate these two factors here by using the fraction form of those as well. So any of these would be acceptable ones. Ideally, again, you can do it by hand, but you can still use those decimal forms and Desmos. All right, a couple more here. Next is systems of equations, easiest ones to do using Desmos because you just type in exactly what you have. Once again, make sure everything is written in terms of x's and y's if they happen to give you any different. And when you do that, the intersection is your answer, -3, -3, for the solution. Okay. All right. Just a couple more left. Again, these ones by hand is going to be how you would need to do them, and that is just a matter of using the properties of slope. We count the slope here. So when we take any 2 points that lie right on the grid marks and just count rise over run. So we go up 1, 2, or we go up 1, 2, 3, 4. We go over 1, 2. Again, we could have used that point I see as well, but up 4 over 2 gives us a slope of 2. A vertical line has a slope that is what? So vertical line, so think about, can you drive on a vertical cliff or vertical road? No, it's undefined, not possible. DNE. Can you drive on a horizontal line? Yes, and so that's a slope of 0. So again, just be aware of those differences. All right. Find an equation that passes through this point here, 7, 5. Oops. So if we plot the point, 7, 5, we see this y-intercept. And notice it's asking for point slope form. Okay, so point slope form is specific, right? Y minus y1 equals m times x minus x1. It's just the slope equation rewritten without it being a fraction. Just cross multiply it. So we know that the point x1, y1 is this point. So we have y minus 5 is equal to, we need to know our slope. We'll talk through that in just a second. And then x minus 7. So all we need to know is our slope. Can we count the slope? Yeah, that's what I would probably do here, is if we go, we count from these 2 points here. We go down 1, 2, 3. We go over 1, 2, 3, 4, 5, 6, 7. And so minus 3/7 goes into our slope, and that's our answer. That's how I would do it. Now, going back to regression, okay, remember this one's asking for a very specific form. Okay, so it wants this form right here. So when you're looking at creating a table, we have a linear equation, has an x power of 1. That means that we need one more than that power number of points. So here, if we take the point 0, 3, and 0, 8, and the point 7, 5, we can then choose linear regression. So this right here, this gives you your equation. Okay, but you can see it's not in the form that it wants. Okay, but we see that this slope here, it tells us is negative 0.428571. Okay, that is equivalent to negative 3/7. Okay, if you entered this decimal value right here for your slope, you would get the correct answer. Now, what if we did the old method of y1 is similar to mx1 plus b? Notice it breaks everything down. We have our slope, we have our y-intercept. Okay, so if you feel like you need to put the rational form from this, if we just type in an m in an empty spot, it's pulling up this m right here. And then Desmos allows you to write a rational form or fraction form of a number. So if I then click this, it turns it into the fraction negative 3/7, confirming again that we did it right by our counting. But the counting is easier anyway. I just wanted to show you how you can use Desmos for those two. All right, the next question here. Hey, what's the slope of this line if you know you're finding perpendicular to the given line? So what you could do is you could graph this and then do exactly, or like if we graph that and found the slope, we could do it that way. So if we type this in, 2y plus 8x equals 9. And we look at our graph. Notice here and here, oops. If you wanted to, you could work through to find the slope of those. Notice this isn't the easiest, it's not the cleanest form. So the better way to find slope is to do it by hand, and that is just solve for y. So if we took this equation, solve for y, subtract 8x from both sides, then divide each term by 2. We get our slope is -4. If the slope is -4, then what does that mean the slope of a perpendicular is going to be? 1/4, right? Change the sign, flip the fraction, and so that would be easier to solve by hand as well. All right, just a couple more here, and then I'll give you whatever time's left to work. All right, we talked about this one. This is also one that's just easier to do it by hand, and that is that the slope is the difference of y's over the difference of x's. So if you just took any 2 points on here and we plug those in, so let's say this is our y, n plus 79 minus our second y, n, over the corresponding x's, -2 minus 0. And we just solve, this is our slope. N minus n gives us a 79, -2 minus 0 is a -2. And so your answer is given. Okay. All right, last couple questions here. The first one's 16. This is one where, once again, if we just build it in our table, we have 2 points. It's a linear equation, so that's all we need. So 7, -9, -12, and 3. Hit the regression. All we need from this is this part right here. So that is our answer. You can put it in there as a decimal. Okay, so -0.631579. So that is your slope. If you're finding this by hand, again, slope is just the difference of our y's over the difference of the corresponding x's. And so if you took -9 minus 3 all over 7 minus a -12, the negatives cancel here. We get -12 over 19. Those are the exact same thing. Once again, it's not very difficult to do it by hand. It's, in fact, it's probably quicker and easier if you're comfortable with that. All right, the final problem here is just converting radians into degrees. Remember, there's a conversion factor, is pi radians is equal to 180 degrees, or 180 degrees is equal to pi radians. You can use either one of these. It all depends on what you're canceling out of. So if we start with what's given, 7 pi over 6 radians. We want the radians to cancel. So we can multiply that where the radians are in the denominator. So pi radians is equivalent to 180 degrees. So now these cancel. The pi cancels. 6 goes into 180 30 times. 30 times 7 is 210. And that is your answer. Remember, you can leave your answer as a calculation in Desmos anyway. And so that just shows the steps.